this is the culmination of all of the notation you've been given. Okay? And as a result, like a supercharged version of this, it's the fastest and most powerful. Okay? So far, we've been naming sets like this by describing which are the actual elements in there, or we've been trying to describe their qualities like, oh, you know, they're all whole, or they're positive and negative and so on. Okay? But if we want to be specific, if you want to build a set with particular characteristics, this is the way that you do it. It still starts with these braces. Okay, so here's an example. Let's call this A. Okay? And then what you do is you name, okay, which set do you want to be in? And then you pick one of those sets we just talked about, those sort of recognized sets like rational, real, etc. Okay, so for example, let's call X, a member of the positive integers. Okay, so the way I read this is, A is the set of numbers X, where X is within the positive integers, there's my universal set, and then I give you a rule. Okay, so for instance, I could say where X is, I'll put it between two things, between 0 and 7. What is this? What is this? This is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. There you go. I've named them all. That's right. Or the order doesn't matter. Okay. So you can see that this tells you a universal set, and this tells you the rules that it fits according to. Okay. You could say, you know, the reason why this is important is because if I were to name, like, say, if I wanted fractions, right, or real numbers in there, I can't list them out. I can't say, oh, you know, if I wanted to say all the fractions between 0 and 7, I can't list them. I can't do it. It would be an infinite set, right? So what I would have to do is say, well, maybe I want X to be all the real numbers. I said fractions, didn't I? Let's go fractions. All the fractions, right? And then I can say, you know, the fractions between 0 and 1, right? Or I could say, let's go real numbers this time. All the real numbers such that I can go from -1 to X to 10 or something like that. Okay? Now the great strength of these is that now I can talk about real numbers, right? You can't do a Venn diagram for real numbers because you'd be writing all the numbers in forever, okay? But if I wanted to do this, all I would have to do is draw something you're super familiar with. This is just a one-dimensional number. Right? I'm just going from 0 to 10, right? Look carefully at your inequalities. Can you see I'm on -1, so that's inclusive, filled circle. Do I get to 10? No. I never actually reach there, but that's my end point, okay? So that's hollow, and then I color in everything in between. Okay? So number lines are a really powerful tool for representing sets. You can even use them if you want to represent integers. So if I did it this way, what have I got here? From 0, 1, 2, 3, 4, 5, 6, 7. There you go. This number line, this set. Okay? So, the reason why this is so good is it allows us to build sets without just naming them all. Because in easy, manageable situations, that's fine. But in other situations, it breaks down.